I've tried to make this point evident as we go through this, okay? Interval width is important when we're talking about estimations, right? It's always going to be an interval estimate. And the width of that is important because, you know, a wide interval is useless to us. If someone estimated, like, you know, how many hours are you going to sleep tonight? Somewhere between 0 and 15. That means nothing. It doesn't really help. It doesn't inform me at all, right? So interval width is an important aspect of that, okay? So if we think about it, there are two things that really drive the interval width, and two things only. The first one is the sample size, right? That is important. That is something we can legitimately control. We can sample more, okay? We can always sample more. The second thing is the confidence level. The confidence level, though, we really can't drop it further than 90%. And if we have very little confidence, even 90% confidence in something, I don't know, if I'm going to make a claim, if I'm going to make a business decision, you know, perhaps I want to be even more confident, 95%, 98%. So really, the big thing that I can change, okay, the big thing that I can change is the sample size. You know, that's the thing that I can really, as an estimator, I can really play around with. I can sample more and get a more precise estimate. So why not sample thousands and thousands and thousands? If that's the thing that makes my estimate better, why not sample thousands and thousands and thousands? Why? Why do I choose not to do that? Leah?
It takes time and money.
Okay. Two things real important in the business world. It takes time and money, right? Whatever it might be, it takes time and money. Sometimes it's very, very difficult to get someone to respond to your survey, right? Sometimes you have to make 100 phone calls to get 6 people to do the survey, or you have to send out 1 million emails, or you have to ask 500 people. So it takes time and money to increase our sample size. The other thing, and I think we mentioned this way back in Stat 301, is sometimes samples are destructive, right? Sometimes samples are destructive. You know, if you think about things like what Consumer Reports do, they sample things and they destroy in the process, like wrecking cars. That's a destructive sample. You know, if I want to sample trees, maybe it requires me to cut down the trees. If I want to sample fish in a pond, maybe I have to kill the fish to sample them, whatever it might be. Okay, so sometimes samples can be destructive. So if we think about this algebraically, and I'm not going to make you guys go through the algebra, but if there's really only two things that control the confidence interval, and we said sample size, increasing the sample size arbitrarily just costs us more time and money. Before we take the sample, maybe we want to know how many to sample to get a certain estimate at a certain confidence level. You know what I'm saying? Like before we engage in this sample, we can ask the question, how many would I need to sample? That's the question. How big does my N need to be for me to get an estimate that I'm 95% confident in, plus or minus some error, okay? Before I even take the survey, okay? Before I take the survey. Now, the thing that we call this, and it relates to both both to sampling estimating the mean and the proportion. If you think about it, when we estimate the mean, we said X bar plus minus. And this thing over here, it goes by different symbols, but let's call it B, or P hat plus or minus B. A lot of times they call this the bound of the error. Okay, the B means bound of the error, like plus or minus 5, plus or minus 3%, plus or minus 4%. It's also called the error of the estimation, right? The margin of error. You've heard that term as well. The other symbol, and your book doesn't use this symbol, but sometimes it's called W. It's called X bar plus or minus W, or P hat plus or minus W. And when you see the W, what that says is it's called the half width, like W-I-D-T-H, not width. Half width. And it means the half width of the confidence interval, right? The confidence interval is the range from the LCL to the UCL. So I don't care what you call it. What we're really trying to do is before we take a sample, we want to know how many we need to sample to get a certain bound of the error at a certain confidence level, okay? Certain bound of the error of estimation, which you see B up here, at a certain confidence level. And let's look at an example, okay? This isn't hard. Let's look at an example. The formula we're going to use is up here. it says when we're talking about, and there's a formula for mean, we're not going to do it, just know that there is. Okay, it's pretty simple as well. But solving for n, when we take that formula, we get this formula. It says n is equal to z sub alpha divided by 2. This is when we're selecting the sample size to estimate a population proportion. What is z sub alpha divided by 2 always related to? It's always related to confidence level. What do you think P is? What do you think P is? Go ahead. Not probability. Proportion, right? And P is what? The population proportion. Very good. And what do you think B is in this formula? What do we say B is up there? What do we call it? It's the bound of the error. It's saying, what is the half width of the confidence interval that you want? Okay. Let's take a look at an example. Maybe I didn't go through that as well as I should have, but let's take a look at this, okay? Suppose that in a brand preference survey, we want to estimate the proportion of customers who prefer our company's brand to within plus or minus 3%. Okay, see, to within 0.03? We said plus or minus, that's the margin of error we want. Our boss, before I take the survey, she tells me, you want to estimate the preference for our brand at 95% confidence, plus or minus 3%. To that effect, we need to know how many we need to sample. So what we're saying, this should say n here, not b. N is equal to 1.96. What is 1.96 there? 95%, okay? 0.03 is what? That's the plus or minus component. Now, P can kind of go two ways. There's two things we can use for P. I'm trying to estimate the population proportion. Maybe I don't know what the clue is. I don't have a clue what the population proportion is. So if I don't have a clue what the population proportion is, I'm going to use 0.5 for the population proportion in this formula. Why do I use 0.5? Because it gives me the biggest number up here. 0.5 gives me the biggest number, okay? And we want to err on the side of caution. Katie?
So you're saying if you can use 0.5 for that any time to make it that size, it doesn't matter what the other numbers are?
It does matter what the other numbers are, but you think about what we're doing, where we're at in the process. We're saying, how many do I need to sample to estimate this population proportion at 95% confidence to within plus or minus 3%, okay? Well, the thing we're trying to estimate, we don't know what it is, P, right? So if we don't know what it is, how can we plug it into a formula? Well, if we don't know what it is, and we have no clue about it, Katie, we're just going to use 0.5. The reason we use 0.5 is because it'll give me the highest number. And remember, sampling more just makes things better, right? So I want to err on the side of caution. Now, if I do have an idea, before I do my sample, if I do have an idea about the sample, the population proportion, maybe I think it's going to be around 80%, I can plug 80% in there. Generally speaking, though, we don't know, so we're going to use 0.5. Okay? So if we do this, in this case, we're going to use 0.5. We're going to come up with this. 1.96, 0.5 times 1 minus 0.5 to the square root, 0.03. Do that math and then square it. We get 32.67 squared, which gives us 1,068. Now, if this comes out to 1,067.3, what do you think we want to do with this? We always want to do what with this? We always want to round up. Why do we always want to round up with this? It's important we round up. Why is it important we round up?
I'd rather have one too many than one.
I'd rather have one too many than one too few, right? Sampling more gives me a better estimate, yes? So let's do one. I think, you know, it makes sense probably just to do one. And let's do one of your homework. So if we go out to chapter 9, and down at the bottom here, you'll see it says calculating the sample size necessary, 4.2, I don't know why I put 4.2, to estimate a population proportion, okay? So let's do the second bullet point I have up there, okay? Since it is Super Bowl time, let's say this. If we have no knowledge about the proportion of U.S. citizens that are planning to watch the Super Bowl, determine the sample size necessary to estimate this population proportion to to within plus or minus 4% at the 95% confidence level. Okay, so if we go to our formula, let's go back to our formula here. Our formula says, if we want to know the sample size, and this should say n, not b, n is equal to z sub alpha divided by 2 times the square root of p times 1 minus p divided by n, and then I square that whole mess. Okay, I square that whole mess. So let's plug this in. So what do I know here? What do I know at this point? What can I plug in, I guess? Well, this is B, I'm sorry. What can I plug in here? Give me something I know from this problem.
1.96.
Okay, 95%, he's right, tells me that z sub alpha divided by 2 is 1.96. Very good. What else? Give me something else I know. Give me something else I know. Sarah?
B is plus or minus 0.04.
Okay, 0.04 is the estimate I want. I want it to be plus or minus 4%. Now the thing I don't know, and this is back to Katie's question, is I don't know what P is. No one's told me what P is. I'm trying to estimate P. So if I have no knowledge about P, what do you think I should use there to make this the biggest? 0.5. So the square root of 0.5 times 1 minus 0.5. All right, so that would be my equation. Let's figure it out. N is equal to, I'm going to do, let's see, 0.5 0.5 times 1 minus 0.5 is 0.25. I want to take the square root of that. I get 0.5 times 1.96 is 0.98 for my numerator, divided by 0.04. I get n is equal to 24.5, and I need to square that. I get 600.25. But I can't sample 0.25 of a person. I can't say, give me a quarter of your response. So what should I do with 600.25? Round it up. And I use little squiggly equal signs. It means approximately 601. So what this is saying is if I sample 601 people, okay, if I get 601 responses, and I figure out the sample proportion, the end result is going to be some number, I don't know what it is, plus or minus what? 0.04. And how confident am I going to be in that? 95%. So you see this is done before I take the sample to say, how many do I need to sample? Does that make sense? When would you do this? Well, if you're like, a marketing research firm, you want to know how big of a sample size you need to take, how many people you need to talk to, because you want to limit this because it takes time and money to do things that are in finite supply in the business world. Okay? Questions on this? All I want you guys to do for homework then for this section is do 16 in your course text, and then I want you to do this third bullet point. Okay, the third bullet point. And there, we have an idea about the percentage of people that read ebooks, 30%. So we're going to use that for P, not 0.5. Does that make sense? Because we have a knowledge. We have some understanding of that. I'll let you know on the test which one to use, but this one we're going to use 0.3. Dan?
I'm just wondering, for next Tuesday, are we going to do a sample exam that day too?
Yes. Yeah. Yes. Okay, questions on this? Okay, so please do those for homework. And if you would, get out your laptops. Hopefully most of you brought your laptops. We're going to do both estimating the population proportion and the population mean with Excel.